All right. So what we're looking at today are residuals. So far, what we've been talking about are given a scatter plot. See the dark points here? That's the data points. And we are giving this best fit line. Here we're given a best fit line, but sometimes we've had to find it. And what a residual is how far off the line of best fit is from each data point. You see, so look here, we got to zoom in real close for this. We see that for this scatter plot, let's see, at time of 1, the point is +1 approximately off of the best fit line. At time 2, the point is -2 off of the best fit line. Okay. And for point 3, it looks like point 3 is right on the best fit line. That's pretty apparent. It'll just be on the line. Okay, so it's not up or down. Okay, we're talking about how far up or down it is from the best fit line. So the way we express that is this new kind of plot. You haven't seen this before. But the plot, actually what it does is it says, well, at time 1, 2, and 3, just like we had over here, 1, 2, and 3, at times 1, 2, and 3, how far up +1 versus how far down -1, -2. Each point is from our line of best fit. This is not the line of best fit. This has nothing to do with anything other than the residuals. This is just a graph to show that at time 1, it's +1. It's +1 above the line of best fit. It's basically the residual is how far off you are. The residuals are like how much of an error it is off of our best fit line. Because the best fit line isn't going to go through all the points. That's not what a best fit line is, right? Best fit is the best guess. So this is saying at time 1, the data point is +1 away from the line of best fit. At time 2, the data point is -2. It's 2 below the line of best fit. And at time 3, because it's at 0, we know that at time value 3, it's right on the line. Okay, just as far as the concept goes, give me a thumbs up, sideways down. Thumbs up, sideways down, just for the concept. What do you think? Yeah. Okay, we got about five thumbs up. Okay, 6, 7. Good. Okay, so that's the larger concept. Now, how we arrive, our final product, what we're going for is to get this residual plot. And, if we just, were able to visually look at how far up and down it is, like in this case, we were able to translate it pretty easily into the residual plot. That would be amazing if they were all just like this. This is kind of like the intro idea, but now we're going to actually use data and we're going to create everything from scratch. Okay, so we're going to do this first problem together. And with this, I need to get out my graph paper, have it handy. Okay, and what I need to do first step, let's scatter plot this. Okay, so just like we've been doing so far this whole time, I'm going to have you organize it like this. You can make your scatter plot. And let's go ahead and just do this hour 1, 2, 3. Let's do, 1, 2, 3, 4, 5, 6, 7. So I know I have enough room to put all that data on there. So that is good. All right. Now let's put in the data. At 1 hour, so this is hours and miles. Okay. So for the first hour, I was able to get 6 miles. I was able to go 6 miles way up here. Okay. 1, 6. At, 1 sec. Okay. At hour 2, for hour 2, I was able to go 4 miles. And at hour 3, I was able to go 5 miles. Okay. So we have a plot here. I'm gonna change one plot. I'm gonna change one thing. I'm gonna change this. Everybody change miles from 6 for 1 here and 6. Let's change that to Let's change that to 2. Okay. So that data point we're going to re-put right here at 2. All right. First step done. First step, make your scatter plot. Step 1, steps. Scatter plot. Okay. Now next, you're going to be given. You don't have to find it for this one. The last exercise we had to actually find the best fit line, but this we're given the best fit line. So next we have to graph the best fit. Okay. That's going to give us an idea of how far off up or down it's going to be. Okay. So let's go ahead and look. Let's go ahead and see. We're going to graph this line. Y is equal to 2x. That's the line we were given. We're given y is equal to 2x. Oh, shoot. Don't redo it, Jeremy. Good job. All right, plus 0. All right. There's only one thing, actually, you'll have to change, Jeremy. One thing on your residual plot. You'll just have to change it at time 1. Okay, so go ahead and make that one change. Okay, so look, this is our y-intercept. It didn't have a value, so I know it's 0. It's our slope. So watch what I'm going to do. I'm going to go down. I'm going to put my y-intercept at 0. Then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to, so I use my slope, rise over run, rise over run, rise over run, rise over run. And then what I need to do is go in here and do what? Do what? We got to connect these points. Let's go ahead and make our best fit line here. And now that I look at that, I'm like, hey, that's a pretty good line. I'm glad they gave us that line. Remember, they're going to give it to us. It's given. It's given. They gave it to us. It's given. All right. So next, we have to use a table. We're going to have to do a table now. Now, we can see that this point is on the line. That point is on the line. This one's going to be a little bit below. So I can already start to visualize what my residual is going to be, right? There's no residual here. It's 0, 0. This is going to be like -1, okay? But here's how we're going to set up our table. Okay, so 3 is set up table. Okay, so what we're going to do is we're going to have hours or hour. We're going to have miles, just like we had before. But what we're going to add are 2 more columns. Leave a little bit of space. 2 more columns in there. So here's what we have here. This is the data. This is the actual data. So at 1 hour, I had gone 2 miles. At 2 hours, I was at mile 4. At 3 hours, I was at mile 5. Here are essentially our x and our y values as far as the axes go. This is the actual. This is the actual. Okay. When you talk about actual versus ideal or actual versus projected, the actual is what actually happened. Okay. So this is what actually happened. And it's slightly different than my line of best fit, you might notice, right? You might notice that. So with my line of best fit, I know it's this. Y is equal to 2x, right? So what I'm going to do is I've already found that after 1 hour, my actual distance is 2 miles. After 2 hours, my actual distance is 4 miles. 3 miles, my actual distance is 5. But I'm going to not find the actual. I'm going to see, well, how about the best fit? What is the best fit projection? Remember this best fit line. I could see what's going on. I could figure out how far I've gone after 5 miles, after 7 miles. I could look on the graph and find where that graph is at 5, where it is at 7. I could also plug in 5 if I wanted to make my projections using the line of best fit. I could plug it in and watch what I'm going to do. I'm going to plug in 1 hour to see where the equation, where the line of best fit is. Watch. Y is equal to 2 times 1. It's at 2. Oh, okay. So my line of best fit matches My line of best fit, the projection matches what I actually walked. Let's do it for 2. 2 times 2 is 4. All right. My projection based on the best fit line matched my actual distance. That's great. Let's do it for 3. 6. My projection exceeded my data by 1 whole mile. Okay. So my actual wasn't as long as the projected best fit at that point. Okay. Now, this is going to be our residual, right? And really what we're doing here is we're going to find the difference. Because the residual is how far off the data point is from the best fit line. Yeah, you got it. So watch what we're going to do. We're just going to do this. We're going to see, okay, well, that's how far I went. That's how far I was supposed to have gone. And watch what I'm going to do. 2 minus 2 equals 0. 0 was the residual. I was off by 0 as far as what I actually did and what the best fit said I was going to do. We keep going through that. 4 minus 4, 0. That's good. So like we have said all along, yeah, the first 2 points were right for hour 1, hour 2. They were right on our best fit line. So the residual is going to be 0. It's not up or down from the best fit line at all. Lastly, we're going to go in here, 5 and 6. 5 minus 6 is -1. It's going to be -1 though, because look, does that make sense? It's down 1. The best fit line said I should have gone 6 miles by hour 3, but I only went 5 miles. It's -1. It's below the line of best fit. That's important. These are now our residuals. Okay, that's our residuals. So now we have to plot that. This is the last step. This is the last step. I'm going to put that right here. Number 4, and this is how I want you to do your graphs. We're going to do a residual plot now. Okay, I want you to line up your y-axis here with this plot. You see how I lined up the axis here and the axis here? This is going to help you. And then I'm going to go ahead and put the residual line here. Actually, it's not like an x-axis. You can get rid of that. So all this is saying is, here's 1, here's 2, here's 3. All this is saying is it's going to help us see, well, what's happening? -1, -2, -3. All right, everybody get that filled out. Get your residual plot ready. Because now we're going to go ahead and plot these residuals that we figured out for each hour duration. So remember what we're doing. The residuals are how far off the actual data points were from my best fit projections based on my equation I'm given. So at time of 1 hour, my residual was 0. Let's see. 1 hour, my residual is 0. So I'm going to put it right there at 0. And I hope that makes sense now. If we look at the original graph, look at 1 hour. It's right on the best fit line. So it makes sense that the residual is 0 at that point because it's right on the line. Now let's go to 2. 2. At hour 2, the residual is 0 as well. Let's see if that makes sense from our graph. Scatter plot, the best fit line. The data point is right on the best fit line. So it makes sense that the residual is 0. Residual, remember, means how far off the data point is from our best fit projection. So I'm going to put that here as well. Okay. And then I want to go in and I want to look at hour 3. That's the last one we have. At hour 3, the residual was -1. The miles that I went was 1 less than the best fit projection. The miles I went compared to the best fit line, when I plugged in 3, I got 6. So I should have gone 6, but I only went 5. So my residual was one less. I went one less than what was projected by the best fit line. So I'm going to put that right there, -1. Well, so the last thing we have to do is this a good fit? Number 5, this is the last step. Is this a good fit? And what do you think? Based on my residual graph, is this a pretty good fit? Yes or no? What do you think? Y or N? What do you think? Best fit graph, residual plot. Not a good fit, huh? No, it is a good fit. It is a good fit because all of the data points that I had, 2 of the points are exactly a perfect fit. The other one is off by 1. Yeah, that's a really good fit. If my residual plot was like one here, one here, one here, another one up here, down here, if it's off by like +3, -3, based on your units, you'll decide if it's a good fit or not. But in general, if the points are pretty close to this 0, so they're very close to being right on the line, then we're going to say, yeah, it's a best fit. It's good. So yeah, it is a best fit. I only had one person respond there. You guys out there? You guys out there in the world? You guys can hear me? Everything's all right? Now everyone responds. Guys, all right, thank you. Thank you for responding that you can hear me. Everyone responds all fast. I asked a question a second ago and nobody responded, so I was confused. All right, thanks. Yes, it is a good fit. Excellent. Excellent. All right, guys, give me a thumbs up. No, let's not do that. I need you to push some buttons on your keyboard. So on a scale from 1 to 5, how do you feel about this topic so far? On a scale from 1 to 5, 2 being, or 1 being, I don't know, anything. 5 is like, got it. All right, good. Thank you for all these answers. I know you exist now. Good. I'm not just sitting in my room doing lessons. All right, good. Excellent. I think if you were like a 5, if you're a 5, then maybe you just need one example. So if you like, you can begin to work on the homework and you could stay in class and just work on the homework. I'm going to do one more example, though, for those that need it. Okay? We're going to do it with this information now. How about this one? All right. Let's see. Let's go hours or hour and money. And let's go 1, 2, 3. Let's go 10, 15, 25. And they're going to give us, given the best fit line of y is equal to 10x minus 2. Okay, so everyone get that much on there. And then you may start to do your scatter plot right below it. So I see it goes up to 15. So I just have to be careful. I'm going to do 1, 2, 3 again. But I might go up. I might do it like 5, 10, 15, 20. Yeah. Again, these are your decisions to scale this as you need it. Okay. Yeah, Marco. All right. So now we have this going on. Let's go ahead and plot. Okay, see it. 1, 10, 2, 15, 3, 25. Okay, so those points don't make a perfect line. Yeah, they don't make a perfect line. So step 1, we just did it. Step 1, we made our scatter plot. Step 2 is to plot our given line. So it looks like -2 is the y-intercept. Here's our b value. Here's our m value. It's 10 over 1. So let's go ahead and plot this, graphing this. If this is 5, that's -5. So I'm going to put the y-intercept right there. -2. We'll call that -2. Okay. Now, if I'm going up 10 and over 1, I'm going to get up to about 8, and I'm going to put a point. So I go up 10, over 1. I go up 10 from -2, get up to about 8. I go over 1. There's 1, so I go over 1, and that's my point. And then I'm here at 8. I'm going to go up 10. I'm going to go over 1. About there. Now I'm at 18. I'm going to go up 10. Guess what I'm going to do? Over 1. Boom, boom, boom. So these points we plotted in blue. The line of best fit that they're going to give you is plotted in red. And we could see that we can make our line. Right? You can count on it being a straight line because we've plotted a line. Shoo. Beautiful. There's our line. And now let's look. Let me know in the chat, a Y or an N. Are we going to have any points, residuals that are 0? Are any of these points perfect on the line? Let's see. No. This one's a little above. No, we're not going to have it. Look, this one's a little above, maybe like +2. This one's below. This one's below. So we don't have any residuals where it's going to be like perfect. Like a residual where it's perfect, remember? Like this. A residual that's perfect is where at 1 it matched exactly on the line, right? Residual that's perfect are going to be on our residual plot right here at 0, okay? But what we have instead, we have, we're going to have a residual that's a little more interesting. Let's make our residual plot right below it. Dang it, I keep doing that. Residual plot isn't an x-axis, it just goes that way. Okay, and we'll put 1, 2, 3. And I'm going to go ahead and wait to put my units for the up and down, because I don't know if it's just going to be up 1, up 2, or up 10 and down 10. I don't know how far off these are yet. So I'd say leave these residuals alone for a second. We just get our plot ready, and now we're going to make our table. Okay, so we're going to make our table. We have hours, we have money. That's what we were given. And then we're going to have our equation, which is our best fit line. And then we're going to have our residual, which is just the difference between those two. Okay. So let's put in what we know. I know at hour 1, $10. At hour 2, we had $15. At hour 3, we had $25. That's a 2 right there. It's a 2. All right, so now think about this. Think about this. Remember, this is the actual, right? That's actually how much money I have in my pocket. Those are the blue scatter points here. Okay. Now, this right here is going to be the projected. The projected, because the best fit, this is our best fit. The best fit says, well, I'm going to say that all of your points basically about are going to follow this line. Is going to follow the red line, the best fit line. But we know that's not true. We know that these data points were a little bit above or below, and that's what the residual is going to show. We have the actual, we have the projected. We'll subtract them and find our residual, how far off it is. Okay, so let's go ahead and do it. I'm going to plug in 1 for my x value. Y is equal to 10 times 1 minus 2. And what do I get here? I get 10 minus 2 is 8. Let's plug in 2. Y is equal to 10 times 2 minus 2, and that equals 10 times 2 is 20, minus 2 is 18. All right, let's plug in 3. Y is equal to 10 times 3 minus 2. 10 times 3 is 30, minus 2 is 28. Okay, so here's what we have. I'll let you get caught up. All right. So we have the actual, we have the projected, and now to figure out how far off the actual is from the projected, we go 10 minus 8. It's just the actual minus the projected, and we get 2. The residual for hour 1 is 2, positive. Okay. Let's do it for the next one. The actual money I have is 15. The projected was 18. So let's see how far off that is. 15 minus 18. Oh, I was off by negative 3. And let's just stop to see if this makes sense for a sec. Let's look at our graph again. At hour 1, was I about plus 2 above the best fit line? Here's the best fit line, about plus 2. That makes sense. How about hour 2? At hour 2, I was minus 3 for my residual. Let's see. The point is about minus 3 below the best fit line. Yeah, that makes sense. So let's do the last one, and hopefully we're not missing anything here. We're not missing anything. All right, let's do the last one. 25 minus 28. Another minus 3. All right. And does that make sense? Yeah, it looks like that point is maybe minus 3 below the line. All the residual is, remember, is how far above and below the line your projected is, your actual is compared to your projected. If you just remember that you subtract them and you use the table method, you'll always get that. All right, and the very last step is to graph the residuals in our residual plot. Residual plot. All right, and then our last question is it a good fit? And that's what we'll do next. So let's look at 1. And now I look at what I have to graph over here in the residual. It's plus 2 minus 3. So I think it's fine to go 1, 2, 3, negative 1, negative 2, negative 3. I think that would be enough. But you see, you got to wait till this point, because what if this was like plus 12? If we had one that was really far off, then your residual plot has to be different, has to be scaled different. So let's see, at hour 1, what was my residual? I was plus 2. I was plus 2 above my best fit line. At hour 2, I was minus 3. I was 3 below my best fit line. See how I put it there at minus 3 for hour 2? Minus $3 from where the projected said I would be. Lastly, at hour 3, I was also minus 3. I got 25 where the projected was 28, so I was minus 3 as well. So I'm down here. Okay. Now, compared to the other one, which was a really good fit because most of them we had 2 points that were on 0. But for this residual plot, it doesn't look like it's a good fit. It doesn't. However, look to see how these units are set up here, right? So because this is 5, 10, 15, 20, 25, 30, right? We let me think about how I want to phrase this one actually. Because our frame of how much money we're talking about, remember this was our money, because our money is going between 0 and 30, if I'm off by $2 or $3, it actually isn't a big deal. It's not too big of a deal. So actually what I would say for this best fit, this is like the question you have to answer. Is this a best fit, a good fit? Good. My answer to that would be the data moderately fits the equation. Okay. And moderate means just like, it's okay. It's not a really good fit. It's not a bad fit. It's moderate. It's like, it's kind of in the middle between those two. Okay. And those are the key parts to it. That's all we have. We have the data points and the equation. We plot the data points, we plot the equation. We set up the table looking at the actuals versus the projected, which is from the best fit equation. And we subtract them to find how far off those two things were. How far the actual is from the projected. Then we plotted that in the residual plot, and we had to answer if it's a good fit or not. Okay? So that's how these problems are going to run through. That's how they're going to run through. Okay? And those are two pretty good examples, I think, actually. You guys feel like any questions coming up? Any questions on that? I'm happy to give you 25 minutes here to work on the homework if you don't have it. I'll give you a second. Think about it. Get caught up. If you're not sure on one part, I can give another explanation on that. I'm going to stop the video, though. Thanks for watching.